Algebra 2, Chapter 2, Section 1, Reordering and Regrouping. Addition and multiplication are both commutative, which is to say they can be reordered. You don't need to worry about this word commutative, just focus on the word reordered. In other words, it's equivalent to write a plus b or b plus a. And this is by definition of addition. 2 plus 3 is the same as 3 plus 2. The sums are commutative, or in other words, they can be reordered. Same with multiplication. 2 times 3 is the same thing as 3 times 2. In addition, addition and multiplication are associative, which means they can be regrouped. Again, don't worry about this technical word. We're not going to have to memorize this word. But we need to remember the idea of reordering and regrouping. We can regroup addition. 2 plus 3, 2 plus the quantity 3 plus 5 is the same thing as 2 plus 3 plus 5. And you might say, well, why'd you use equals here? Because this is I'm dealing with values. I'm giving you an example. Remember, there's 3 bars here because these are equivalent. We can substitute this expression for this expression no matter what values of a, b, and c that we pick. Back to the idea of equivalent expressions. And we can reorder multiplication. 2 times the quantity 3 times 5 is the same as 2 times 3, all that times 5. What about subtraction? Subtraction is a little trickier because we cannot just write this. This is not equivalent. A minus b is not the same as b minus a. What is equivalent is that a minus b is equivalent to a plus negative b. And by the reordering of addition, also, this is equivalent to minus b plus a, which is then therefore equivalent to minus b plus a. So while we cannot reorder subtraction, we can turn subtraction into addition by adding the negative, and then we can reorder or regroup the resulting addition. Let's look at example 1. In example 1, it says, in each of the following, an expression is changed into an equivalent expression by reordering addition, reordering multiplication, or by regrouping addition or multiplication or combination. Which principles were used where? So he starts with A. X plus 2 times 3 plus y equals 3 plus y times x plus 2. Well, in this case, the x plus 2 went from the left to the right, and the 3 plus y went from the right to the left. So this is an example of reordering multiplication. And now if we look at part C, 2c times d is equal to c times 2d. Well, the first thing he did was he regrouped, but he's also reordered. See, we have 2 times c times d, and here we have c times 2d. So first we need to reorder inside here to c times 2d equals c times 2d, and that's by reordering multiplication. And then by regrouping, we can write c times 2d. And now looking at example 4, we'll have a more challenging problem. Let's clear the page off here. Example 4 says, if x plus y plus z is equal to 1, then find the value of this expression, x plus 10 plus y minus 8 plus z plus 3. So at first this doesn't look possible. We don't have x plus y plus z in this expression. But by reordering and regrouping, we should be able to create a sum of x, y, and z, which we can then use this definition to substitute 1 for x plus y plus z. So first, let's reorder the addition by dropping the parentheses. We can do that by reordering of addition. The only problem is that we need to be careful with the minus. We need to remember this principle to help us with reordering subtraction. So let's make this a plus negative 8 to deal with the negative, this minus sign. Now we can freely reorder the additions. By reordering now, we did regrouping here. Now we can freely reorder. So we can do x plus y plus z. So x came from here, y from here, z from here. And now plus 10 plus negative 8 plus 3. And now we have x plus y plus z. X plus y plus z equaled 1. So we can write 1 in its place. And now if we add these up, 1 plus 10 is 11. 11 plus negative 8 is 4. Sorry, 3. And 3 plus 3 is 6. And now we have found the value of the expression. What about when we have like terms? So this means when we have an expression like this, where we have an x with one coefficient plus an x with another coefficient. Well, we can use the principles of adding like terms to add the coefficients. This equals 10x. These are called like terms because the x has the same exponent. Here the exponent is not written because it's just 1. So let's do a bigger example. What if we had 7x squared plus 3x plus 4x squared plus 2x? And we're told to simplify this expression. We can reorder the addition to get the like terms with the powers of x next to each other. And now we can add the coefficients. 7 and 4 is 11. 3 and 2 is 5. We only add the coefficients of the like terms, the terms with the same power of x. Let's look at example 5, part A. It asks to combine the like terms in this expression. 3x squared minus 0.5x plus 9x minus x squared. So again, we need to reorder the addition, but to do that we need to remember we have subtractions in here. First we need to make this an addition by adding the negative. Now we can reorder 3x squared plus negative x squared. Is that a better plus? Plus negative 0.5x plus 9x. So now we have like terms. We can add the coefficients, 3 and negative 1. Adding those coefficients gives us 2. Negative 0.5 and 9. Adding those gives us 8.5. 8.5x. And now let's look at example 6. Example 6 says simplify 3 times x plus 3 minus x minus 14. First, we need to rewrite this multiplication by multiplying the 3 to the x and the 3 to the 3. We're going to talk more about this in the next section. 3x plus 3 times 3 minus, we need to turn into a plus negative. Now, combining like terms, I'm going to skip the step of reordering. I'm just going to go find the like terms. Here we have 3x and we have negative x. 3x and negative x makes 2x. 3.3 and negative 14. Sorry, not 3.3. 3 times 3 is 9. So 9 plus negative 14 is negative 5. And now we have the answer, 2x minus 5.